Hi everyone, welcome to my channel. I'm Thiago, and this is the second video on my series of videos on algorithm challenges, in which we are diving into solving some of the most exciting algorithm, computer science challenges that I can find on the internet. Today we are tackling problem number 2 of Project Euler. The title of the problem is Even Fibonacci Numbers. Each new term in the Fibonacci sequence is generated by adding the previous two terms. By starting with 1 and 2, the first 10 terms will be 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. Yes, this is the Fibonacci sequence. If we add the two numbers, we get the next. So 1 plus 2, you get 3, 2 plus 3, you get 5, 5 plus 3, you get 8, and so on. It's an infinite sequence. By considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of even valued terms. So we want to find then the even values within this sequence. The even values here would be 2, 8, 34. The next one here will be 144. Yeah, we can make a simple implementation that will loop through the numbers of this sequence. And if we find an even value, we just get it and sum it. That should be pretty straightforward, a pretty simple algorithm that we can create. Right, so let's give it a try. Right, so here we are in our IDE. Let me create a new directory for us to put our new problem, problem number 2, and a new Python file as well with the same name. Yes, I want to add it. So first, I want to define a few variables to solve our problem. The first one is the threshold. Threshold, it's the name of my variable. That will be the limit that we want to stop if we don't want to look further than that because the problem doesn't ask us to. And we also want to define the sum. I'm calling it X here, S here, but yeah, you can give whatever name you want. And I'm going to define two variables for our Fibonacci sequence, which are the previous two numbers to generate the next number of the sequence. I'm going to call them A and B, starting with 1 and 2. Why 1 and 2? Because this is our problem. They are the two first numbers of the sequence. We need to start somewhere. So with these two numbers, then we can just loop through the entire sequence, checking which ones are even. To do so, I'm going to use a while loop. While one of these numbers, A or B, I'll get the biggest one, B, is smaller than our threshold, right? And okay, with our threshold then, at each iteration, I want to check which one is the even number. So I'm going to check if B, the remainder of the division by 2, if it's 0, then we have an even number. And if that's the case, then I'm going to add it to my sum, right? Now we need to generate the next number of our Fibonacci sequence. To do so, I'm going to create here, instantiate a auxiliary variable that will be the sum of the two numbers, right? And then I will update the two previous numbers with these new variables so that we can do in the next iteration, we can continue the sequence in the next iteration. So A then will take the value of B, and B will then take the value of the auxiliary variable. Then we update the sequence to generate the next iteration, right? This should, in theory, do the trick. Let's just print the result here of our calculation. And just following here the Python coding conventions, right? Yes, that is right. Yeah, that should do the trick. Let's give it a try. Python problem 2, problem 2. Yeah, so running the code, we get a result here. Copy and paste it and see how it goes. So I got here the result. If we go here, let's paste the answer here. And let's check. 3, 2. Dun, 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 dun. Yes, the answer is right. So this is the result. But one thing that is interesting for us to analyze here is how complex is the solution, right? So in this solution here, I have a linear complexity. I'm going through every number of the sequence just once, just passing through the entire sequence. So I have a linear complexity. And it's also interesting to see some of the operations that we do here. So for example, the operation of division, it's an expensive operation. We have to divide the number, get the remainder, and check the result. First of all, I want to check here how much time it takes for us to run this sequence and how much faster we can make another code to do so. So I'm just going to do an important datetime here and just going to log the time to do this operation, this entire code. Right? A simple profiling of the code, right? Just going to do time is equal to datetime.datetime.now minus the start time. So let's see how long it takes. It is actually really fast to run this code. This code is, a computer can just loop through the code very fast. But there is actually a better way to implement this. So let's go here for solution number 2. There is a solution 2 to the same problem, right? And the solution is relatively simple. If we check the sequence, the Fibonacci sequence, which starts as 1, 2, 3, 5, 8, 13, 21, 34, and so on, right? We can check that actually the even numbers that we're looking for, so 2, 8, 34, they're actually spaced within 2 numbers of the sequence. So we have an even number and then 2 odd numbers and then 2, and then another even number and then 2 odd numbers. So if this is the case, can we come up with a formulation that gives us the next even number of the Fibonacci sequence without having to loop through the odd numbers? The next number of the sequence can be given by the 4 times the previous number plus the previous number. As you can see here, the number 8 of this sequence, 8 is not a good example, but for example, the number 34, it's 4 times 8, which gives us 32 plus 2, 34. So let's give it a try to implement something like that, right? So the threshold will be the same. The sum here will be also the same. And let's start the 2 numbers of our sequence with the 2 first even numbers of our calculation, right? So A should be the first and B should be 8, right? And since we're starting with 2 here, which is an even number, my sum will also start with 2. And we can do the same thing while B is smaller than the threshold, right? And here we're gonna do something different. S will always sum B, right? Because it's always a even number. And what then will be our new auxiliary number? It will be 4 times B plus A. That's it. And the 2 other parts are the same. A will always receive B. B will receive the auxiliary, right? And this should be the result. So let's just print S here. And for the sake of comparison with our previous solution, I'll also print the time, right? Because it's useful for us, but I guess the difference is not going to be so big because this is not a very complex problem. Yes, so we just executed. We can see the time is slightly less, but as I said, the problem is not so complex. The result is the same, so we know that it is correct. We already solved the problem. Thank you so much for watching. Please feel tuned for us to solve the next problems of this website. Like the video, share, subscribe, and turn on the notification bell for next videos. And that's it. See you in the next one. Ciao.